I'm Sensei Allison from Code Ninja's Wellesley. Today, I'll be talking to you about how you can store important facts about gameplay when you're making a computer game in JavaScript. This is the first in a series of videos about important computer science concepts as applied to JavaScript. Let's say that you want to add a score to your game. Or your character should have a certain number of lives in their game. Or maybe you want the person playing your game to be able to give their character a name. Or maybe you want to remember whether the player has clicked a button before or used a power-up. How does the computer keep track of these things? Think about how you identify people, animals, and things in your life. You know lots of things about them, like the color of their hair or eyes, whether they're tall or short, how old they are, how heavy something is, whether you should pet an animal or not. You remember all these facts about the person, animal, or thing when you think of their name. Computers give names to facts too. They don't know what fact you want them to remember, so they make an empty box for you to store your fact inside, and then attach the name you gave it to the box. These named boxes are called variables. There are a few different types of facts that you can store in the named box: numbers, letters and words, and true or false values. Let's look at a few examples of variables and the things they store. We'll be looking at JavaScript variables, but every computer language has their own version of variables. Take a second and decide which category each of these examples falls into: number, letter or word, or true or false value. The first three are numbers. Notice that we can store both positive and negative numbers, as well as whole numbers and numbers with decimals. You've got to use decimals instead of fractions, since the computer doesn't quite understand what you mean when you try to type a fraction. Some numbers don't make sense stored in certain variables. For example, you can't be -5 years old or have 3.5 cats in your house. The computer doesn't know that these are nonsense values. It's up to you as the human programmer to see these as nonsense values. Your brain is a much more powerful computer than the one you type on, so it can recognize context clues. The fourth, fifth, and sixth examples are stored letters and words. You can store uppercase and lowercase letters, spaces, punctuation, numbers, and any combination of those. Another word for any letter, space, punctuation mark, or number is character. Notice that there are double quotes surrounding all of the characters. These quotes tell the computer where the letters and words to store begin and where they end. The seventh and eighth examples are true and false values. Think of these like a light switch. You can turn a lamp on and off, and the switch holds the last position you flicked it into. Let's look at a bigger example. This is a simple animation of a ball bouncing around a screen. There are lots of things that the computer has to remember in order to make the ball look like it's bouncing, because really, the ball is a circle that the computer redraws many times a second. To redraw the circle, the computer needs to know how big the circle should be, what color it should use, and where on the screen it should be. Check out all these variables. We have numbers and characters here. As we scroll through the code, we can see them used so that way we can ask the computer what it's storing in the box named, say, canvas width, canvas height, canvas color, this.radius, and so on. I bet you're wondering why some of these lines of code have sequences of variable names in them, like this.radius or gamearea.context.fillStyle. Those are clues to the computer about which larger boxes contain the specific smaller boxes that we want to open. We'll talk more about these bigger boxes and smaller boxes in later videos. We can get overwhelmed pretty easily by things to store, so this system of putting smaller boxes in larger boxes and using this naming pattern allows us to stay organized and associate specific numbers and words with each other. Think of, say, your school library. They use the Dewey Decimal System. Everything has its own place, so that way you can find it. This is our Dewey Decimal System. Let's try to think about how you might use variables in a game that you would build. I love doing Sudoku puzzles, so I'm going to think about how variables would help me make a Sudoku game. If you don't know the rules to Sudoku, here's a quick lesson. Each one of these little boxes has to have a number between 1 and 9 in it. There can't be two of the same number in any row, column, or big box. To play, you start with a few numbers filled in for you, like these dark black ones, and you fill in the little boxes that start out blank until you find a configuration that follows the rules I just described. How might I make a Sudoku game? Well, the computer will have to remember a few things. It'll have to remember whether each box is blank or not. What kind of variable would that be? It'll have to remember whether each box should be changeable by the player or not. Which kind of variable would that be? It'll have to remember which number should be stored in each box. Which kind of variable would that one be? Now that we have these handful of variables, what checks might you perform to see if the solution was correct? Take out a pencil and a piece of paper and write and sketch out your thoughts. It's okay if you don't have a fully functioning Sudoku game. We're just trying to stretch our brains. Thanks for watching, and good luck with your variable voyages.